Welcome to the awesome video project featuring me, Melissa Farguson, and
me, Naisha Gonzalez.
Momentum is a conserved quantity. The equation for momentum is P equals mv. M is mass, v is velocity, and P represents momentum.
This is a collision. In physics, a collision is defined to be an interaction in which two objects strike each other. In this example, the objects striking each other are the car and the wall. During a collision, momentum is conserved, but it is common for some, if not most, of the kinetic energy to be lost or converted to other forms, such as sound, heat, or deformation. There are two examples of collision, known as elastic and inelastic. In an elastic collision, the total kinetic energy before and after are conserved. In an inelastic collision, the kinetic energy after the collision is less than the kinetic energy before the collision. If two objects stick together after the collision is said to be perfectly inelastic. In this type of collision, the maximum amount of kinetic energy is lost due to sound, heat, or deformation. The sound is when the car hits the wall, making a loud bang. The car is being deformed by the wall, and the heat comes off when the car hits it.
Potential energy is found using the equation m times g times h. Kinetic energy is found using the equation 1/2 mv squared. Energy is measured in joules. Mass is m in both equations. Gravity is g in potential energy equation. H is height. V is velocity. A small block of mass, 2m, initially rests on a track at the bottom of the circular vertical loop-the-loop shown above, which has a radius r. The surface contact between the block and the loop is frictionless. A bullet of mass m strikes the block horizontally with initial speed v0 and remains embedded in the block as the block and bullet circle the loop.
This is the diagram we will be using to solve this problem. Point A and B are where the collision takes place, and point P is where it will use for part B.
In part A, you're asked to find the speed of the block and bullet immediately after the collision. First, you would have to draw a free body diagram. The free body diagram will consist of the bullet traveling at an unknown initial velocity towards the block. The after picture would show the block and the bullet combined with the mass of 3m going at a final velocity that is unknown. To find the momentum, you would have to set the initial momentum equal to the final momentum. The equation would look like m times v initial equals 3m times v final. You would cancel out the m's, which is the mass on each side, because there is a mass on each side. Then you would divide what is left over by 3, and you would find the final velocity by using the initial velocity divided by 3.
In part B, we are trying to find the kinetic energy of the block and bullet when they reach point P on the loop shown in the diagram above. To find the kinetic energy at point P, we will set the initial energy equal to the energy at point P. Initially, we are traveling, which means you will use the equation for kinetic energy, which is 1/2 mv squared, and we will set that to the energy at point P, which is kinetic plus potential. So we will have kinetic at point P plus mgh, and we can substitute r for h in the diagram because r is the height at point P. So in the next step, we will substitute all our givens, and it will be 1/2 times 3m times the final velocity we found previously, which is v initial divided by 3, and then we'll square that, equals kp plus 3mgr. We will continue to solve it, and we will do 3m times initial velocity squared divided by 2 times 3 squared minus 3mgr equals kinetic at point P. We will cross out the 3 on top and the 18 on bottom because 3 goes into 18 6 times, so we will have mv o squared divided by 6 equals 3 mgr equals kinetic energy at... Congratulations, you just did a physics problem. The world's hardest problem. But you